So there are three types of forces due to the magnetic field. First one is force on moving charge in magnetic field, and second one is force on current element in external magnetic field, and third one is forces between two current elements. Now coming to the first one, so forces on charged particle. Suppose stationary charge or moving charge in electric field, there is a force exerted on that. F is equal to QE, and F E in same direction for positive charge. So force in electric field is equal to QE. So Q may be stationary or moving, right? Suppose the force on moving particle, moving charge Q in magnetic field having magnetic flux density B is given by Fm is equal to Qu cross B. So Q is the charge of the charged particle and U is the velocity of the moving charge particle and B is the magnetic field. So magnetic force direction is perpendicular to U, magnetic force is perpendicular to B. So magnetic force is perpendicular to both U and B. Okay, now coming to the differences between Fe and Fm. Fe is independent of Q, independent of velocity of the Q. It will do some work. It will change the kinetic energy of the Q. Fm magnetic force, it doesn't work anything. Depend on velocity of the charge particle. So Fm is far less than Fe except for high velocity of charged particle. If Q is moving in both magnetic field and electric field, then so total force exerted on charged particle is equal to Fe plus Fm. So Fe plus Fm equal to Qu plus Qu cross B. Q cross B. Take common Q into electric field intensity E plus U cross B. Right. So this force is equated to force is equal to MA. This is Newton's second law. F is equal to MA. So M is the charge of the mass of the particle, and where A is the rate of change of velocity du by dt equal to Q into electric field intensity U cross B. Okay, this is the force due to the electric field and magnetic field. Now coming to the force on current element. So we know that a relationship, three current relationships, ideal is equal to KDS equal to JDV. So ideal equal to JDV, but we know that current density is equal to volume charge density into velocity of the charge of particle, velocity of the free electron charge U, right? So this is substituted here. Ideal is equal to JDV means rho V into U into dV. So we can write rho V into dV and U. So what is rho V into dV? It is nothing but differential charge Q. So ideal is equal to dQu. We know that F is equal to QU cross B. Force exerted on charged particle Q. So differential force exerted on the charged particle dq, df equal to dq q cross b. So this is the differential force on differential charge dq. right? Then df is equal to dq is equal to ideal. We already seen what is dq we got here. So dq is nothing but ideal. dq is nothing but ideal, right? So dq is nothing but ideal. So in the place of dq we can write ideal cross b. So this is the force on current element ideal in magnetic field. Now coming to the, if I is a current flowing through the complete closed circuit, what is the force on the circuit, complete closed circuit? So that is equal to, you have to take integral, closed integral, f is equal to closed integral of ideal cross b. Okay, so this is a force on the only ideal, but this is a force on complete circuit. So you have to integrate it. Similarly, force on current sheet having current density is k amperes per meter. So in the place of ideal you have to write kds. Similarly, force on volume current. So simply you have to replace ideal with jdv, and integration is volume integration. So this will become force on the volume current distribution, volume current. Okay, so if we observe first equation, so we can write b equal to force by ideal, f by ideal. So f unit is newtons, right? So newton for 1 unit current length, 1 unit current element. So what we observation is the unit of the magnetic flux density is changed to newtons per current unit current element. Now let us see forces between two elements, two current elements. Consider there are two current loops as shown in the figure. This is circuit 1 and this is circuit 2. The I1 is the current in the circuit 1, I2 is the current in circuit 2. Okay, so here I2 L2 current element, here I1 DL1 is the current element in circuit 1. So this I2 DL2 current element in circuit 2, right? So there is a distance between these two is R21, R21 from 1 from here to here. So there is a force, differential force on 1 on I1 DL1 due to the magnetic field is developed by second current circuit, second current circuit. Okay, so as per Bayes-Savart law, so magnetic field strength on I1 DL1, first current element, current element due to the sorry. So as per Bayes-Savart law, at the point of I1 DL1, there is a magnetic field strength at the point of I1 DL1 is due to the current element I2 DL2. So that is given by DHT is equal to I2 DL2 cross AR21 by 4 pi R21 square. Okay, so R21 is the distance between the source point and at this point at which we are finding the magnetic field strength dH2. This dH2 is due to the I2 dL2 current element in second loop, and where R21 is the distance between from here to here. Similarly, we have dH1 due to the B1 of loop 1, right? So we can also write dH1 I1 dL1 cross AR by 4 pi R12 square. Okay, okay, so the magnetic field strength at this point tau I2L2 due to the magnetic field produced by the second current loop, first current loop, that is dH1. dH1 is equal to I1 dL1 cross AR12 by 4 pi R12. This is Biot-Savart law as per Biot-Savart law. So differential force on I1 dL1 due to the V2 of loop 2 is given by TF1 is equal to I1 dL1 cross B2. So this is a force formula. Okay, and double derivative of F1 equal to I1 dL1 cross dB2, so where dB2 is produced by I2 dL2, I2 dL2, right? So what is the dB2? You know already B is equal to mu naught H. So dB2 is equal to, you have to multiply mu naught into dH2. So mu naught is multiplied to the dH2, mu naught into I2 dL2 cross AR21 by 4 pi R21 square. Right. R21 square. So double derivative of F1 equal to I1 dL1 cross, and this term is, entire term is B2 dB2. So this whole term is substituted here. So mu naught I2 dL2 cross AR21 by 4 pi R21 square. This term is substituted, right? So double derivative of dF1 is equal to, so take the mu naught outside, mu naught I1 dL1 into I2 dL2 cross AR21 by 4 pi R21 square. So if you observe this is I1 dL1 into I2 dL2. Actually it is cross. Okay, it is just like a law of force between two elements, just like Coulomb's law. Q1 Q2 by 4 pi R square. The force is equal to. So similarly, this formula looks like Coulomb's law formula. So this is the law of force. Coulomb's law is meant for law of charges. This formula looks like a law of forces. I1 dL1 and I2 dL2. First current element and second current element. And this is the distance between first current element and second current element. It is just like a law of force as Coulomb's law of force, law of charges, right? Now what is the force, complete force on loop 1? So you have to integrate. So mu naught I1 I2, take it outside, mu naught I1 I2 by 4 pi, and put the closed line integral L1 and L2. So dL1 cross dL2 cross AR21 by R21 square. Okay, so this is the force on loop 1 due to the loop 2. So what is the force on loop 2? What is the force on the loop 2 due to the loop 1? Due to the loop 1, just you have to interchange the subscripts. Right here, here I1, I2. You put I2, I1. Okay, here it is DL1. Put here DL2. Here it is DL2. Put here DL1. Here AR21. You have to put here AR12. Right? So here AR21, R square 21. Here put R square 12. R square 12. That's all. Just by interchanging subscripts, you will get the force on the loop 2 due to the loop 1. So what is the relationship between F2 and F1? F2 is equal to minus F1. Okay, so this is the force between two current elements. Okay, so basic backbone of this formula is differential force on I1 dl1 due to the magnetic field flux density B2 of second loop. This from this onwards, this equation is derived by step by step. Right? This is the magnetic force formula, and this is Biot-Savart law. This is from Biot-Savart law. So two are the main backbone for this topic, for this derivation. F1 is equal to this one, F2 is equal to this one, and this is the relationship between F2 and F1.